Let's jump right into this explainer and explore the genuinely fascinating world of LED screen repair. Today, we're zooming all the way from massive, macro-level system issues right down to microscopic chip soldering. Because LED displays are fundamentally modular systems. A fault can pop up anywhere, at the individual bead, the module, the cabinet, or the entire system level. And honestly, efficient troubleshooting is the name of the game here, right? It's what drastically reduces downtime and saves a ton of money.
So to keep things logical, here is our roadmap for today. We're looking at system and cabinet diagnostics, unmasking visual module faults, the driver IC deep dive, advanced soldering and pad repair, and finally, post-repair testing procedures. Let's get to it.
So picture this, it's right before the big game and a stadium-sized screen suddenly shows massive black patches. When you're staring down a wall of thousands of blank or glitching pixels, it can feel, frankly, totally overwhelming. But take a breath and remember, these are just manageable modular systems. As technicians, we just need to calmly isolate whether it's an issue with a module, a cabinet, or maybe just a sending card.
And here's some really good news. The crucial takeaway is that a vast majority of these terrifying display failures, we're talking about 90% of them, actually come down to a basic short circuit. Yep, it's usually just a localized problem that we can easily detect and fix, rather than some catastrophic whole system meltdown.
All right, moving into Section 1, System and Cabinet Diagnostics. Let's start with the macro troubleshooting. Now, this is where it gets really interesting. You can isolate a system fault incredibly fast just by reading the indicator lights on your hardware cards. It's like they're talking to you. For example, on a sending card, a green light flickering usually just means normal startup or no video input from the PC. But a fast red flicker, that actually means your software license has expired. Crazy, right? Over on the receiving card, a steady red light tells you power is A-OK. But if you spot a green flicker at a super slow 0.2 hertz, you've definitely got a broken signal cable. A fast 7 hertz flicker? That's a boot error. So before you panic about a dead screen, check the lights. You might trace a massive issue back to a simple loose cable rather than a hardware failure.
When the indicators do point to a hardware board issue, we rapidly deploy a systematic multimeter process to find the culprit. We always start with our trusty short circuit detection. Now listen carefully. It is absolutely critical that the power is completely off during this, unless you want to blow up your multimeter. If the short circuit test doesn't reveal the issue, we move on to resistance, voltage, and voltage drop detection by comparing readings from our faulty board against a perfectly functioning one.
Which brings us to Section 2, Unmasking Visual Module Faults. It's time to decode those weird screen glitches. By using this simple symptom, cause, cure framework, you can instantly translate a dreaded display glitch into actionable repair steps. Do you see a worm effect or caterpillar of abnormal brightness streaks? That's likely a short circuit in the lamp tubes or some PCB tin bridging. Just clean up the solder bridges or swap the faulty beads. What if a whole color channel is missing? Your data signal is shorted or the 74HC245 IC just failed. Is half the module completely black? Again, that's 74HC245 IC as your prime suspect. Understanding this visual language is literally your shortcut to the perfect fix. Let's dive deeper into that hardware with Section 3, the driver IC deep dive. It's time to physically identify these notorious chips. First up, the 74HC245 chip. This little guy handles signal amplification and buffering. So if half your unit board is completely dark, or if you're seeing entire rows dropping out, this chip is usually the very first suspect you need to pull in for questioning. Next, we have the MBI 5024 driver IC. When this one goes rogue, you'll see those blindingly bright, annoying lines, missing columns, or massive missing color blocks on the screen. It directly manages the specific red, green, and blue color outputs for a group of LEDs. Finally, meet the 4953 chip. If entire rows are just vanishing on your scanning screen, you need to hunt down and inspect this specific line management chip. A short circuit here takes out horizontal rows in an absolute instant. Now, here is a fantastic pro tip for finding exactly which IC is broken among the dozens scattered across a board. Driver ICs usually have 24 pins, with 16 output pins sending signals directly to the LEDs. This means one IC controls exactly 16 columns of LEDs. You can literally just count the pixels across the board. If a color block appears right around the 15th column, boom, you know it's the very first IC in that group. It is a beautifully simple mathematical map straight to the faulty chip. Moving on to Section 4, Advanced Soldering and Pad Repair.
We are officially at the micro level now.
For this kind of surgical work, you're going to need a very precise toolkit. And you absolutely have to pay special attention to your soldering iron's temperature. You need it cranked up to around 370 to 400 degrees Celsius to melt the solder for those IC chips. But for the LED beads themselves, you've got to drop that down to 300 degrees. Too much heat will literally melt and permanently destroy the delicate LED encapsulation and the components around it.
Sometimes swapping a dead pixel isn't quite as simple as popping on a new bead. A cracked LED bead can actually lift and rip the delicate bonding pad right off the PCB. When that nightmare happens, we have to execute a rescue. You can try to rebuild the pad with conductive copper foil, or you can use the flying wire technique. This is where we manually solder a bridge from the broken pad to the nearest functional pin, using a microscopic 0.1 millimeter copper wire.
But hold on, you can't just run a flying wire anywhere. You must strictly follow the proximity principle during this microscopic surgery. Remember, the LED has 4 pins: power, red, green, and blue. If a color pad is missing, you must only bridge it vertically, straight up or down, to the exact same color pin of the nearest LED. If the power pad is missing, you bridge horizontally, left or right. If you cross these wires up, you will completely scramble the screen's colors, and nobody wants that.
Okay, the fix is in. Section 5, Post-Repair Testing Procedures, because a master technician never packs up without validating the repair.
You really want to run through this exact testing checklist every single time. Check your red, green, and blue channels completely independently. Display a full white screen at low, medium, and high brightness levels to catch any hidden weaknesses. Check your grayscale gradients, especially dark gray. A scanline test is absolutely vital here. If you see 2 lines light up at once, oops, you've accidentally bridged some pins with solder during your IC repair. And always, always look at the module from side angles. Even a perfectly working, newly soldered LED can look like a dead, dark patch if it's tilted even a fraction of a millimeter. And remember, your environment matters immensely. If you're working on an outdoor screen, you must carefully reapply the waterproof, anti-corrosive glue around the board edges. Skipping this step practically guarantees the panel will fail again after the very next rainstorm. Indoor screens need totally different care. Think anti-static gloves and strict humidity control. For indoors, you specifically want to maintain an environment between 10 and 65% relative humidity, maybe even using a dehumidifier before powering up, just to keep those sensitive electronics safe. Proper preventative maintenance, combined with these logical troubleshooting steps, is really all it takes to conquer any LED failure. Believe it or not, the industry failure rate is incredibly low, around 0.03%, when these screens are cared for properly. From deciphering those blinking indicator lights to executing microscopic flying wire repairs, you now have the ultimate roadmap. So what screen are you going to fix first?